I think we're good to go. It's 1 minute past sharp. Thank you for being here. I think every speaker in the conference told you that how nice it is to actually see people in flesh and bones. In the last 2 years, I did only online presentations, and it's not nice to not see people staring at you or making funny faces or getting bored. I hope it won't be the case today. But let's talk today about gRPC. gRPC has been around for quite a few years, but not in the .NET ecosystem. And I chose this because I always like to talk about different tools and technologies that we have available so that the developers can be able to make an informed decision when it comes to picking the right tool for the specific problem they have. So who am I? My name is Irina Scurtu, married name Dominte. I'm from Romania. So I really love Portugal, the language, the food, and the wine. I think every speaker told you that. I'm a software architect and an independent consultant. I organize a group on Microsoft MVP, and I often blog, not that often lately because I have a small child, at Irina Codes. You can find me on Twitter. I always tweet about my blog posts. So we will get started about gRPC, but not until we're going to talk about the monolith. Who here, because I see a lot of people my age, have worked with monoliths before? Who loves them? Oh, admit it, it was easy life. I worked with monoliths since, I don't know, 15 years ago, 12 years ago, and the life was very easy for a developer because you loaded the solution, everything loaded with that solution, and when you pressed build button, you could go ahead and grab a coffee because the build always took many minutes. The life was easy for a developer because everything was in there. If you ever needed a class, was in there. You went ahead and you instantiated that class, used the functionality, called the method, and everything was there. But, well, kind of every application, web application, looked like that. It has the front end and the back end. We had onion architectures, everything in one place. Database or several databases and so on. But now, everything is working to be distributed. We split the front-end app. We have React, we have Angular, we have whatever JS applications, and we have an API to serve data. And it doesn't matter what databases we have in behind of it. But the future is distributed, and we need to adapt to the challenge of serving requests faster and more requests because the storage is cheap and the user wants the responses very fast. So now we might end up having a front end that talks with different backends, and those backends maybe talk with other backends, so API to API calls. And then maybe we get to this kind of situations. We have .NET apps that need to talk with a Go application or Node.js or third-party APIs that we do not know the language. We know the definition of it, but that's it. So that's a common scenario in the world of microservices, right? You have smaller chunks, and those chunks are needed to talk with each other. And that talk is often made in JSON, right? Because JSON is the common language for pretty much everything. And, well, we have REST APIs. Admit it, you did REST APIs? You implemented such APIs? You did, right? So, and those APIs were following every REST guideline? No, right? More often than not, though our APIs, I know from experience, my APIs were like transporting JSON over HTTP. They had a few things with REST, but that's it. Weren't RESTful enough to actually name them as being RESTful. So REST has something like that. We have a client, we have a server, and in between, we often have content negotiation done under the hood. So that content negotiation takes care of the format of the request, the payload, the error handling and the retries, and also the authentication. Everything is self-contained in those requests. We have headers, we have verbs, and the server understands what we want based on what we sent. Okay, if we send content type of a specific MIME type, it will give us a specific response back. If we send another MIME type, maybe it will send a different representation of that REST source. But REST has a problem. REST, or JSON over HTTP, has a lot of issues. It becomes very chatty. I mean, it forces you to go over the network to bring data, and then maybe go again over the network to bring some more data. And that's why a lot of technologies like GraphQL are very popular right now, because it gives the client all the control. Okay? So another thing that REST does very well is forcing team collaboration. If you have a client application that is developed in your team and you have front-end developers, you might go to them and say, hey, add that field because it was added in the backend, and so on. But if you do not own the client app, what do? You always need to go and take care of the breaking changes. Okay, if you expose an API and that API is consumed by don't know who, or whom, or what application, every change that you made, you need to make it with care, because you don't need to break your consumers, okay? So this chattiness from the REST APIs can easily be overridden or forgotten by using remote procedure calls. So remote procedure calls, it's a concept that's here from the 70s. It's an old concept. You know, these concepts have a tendency of getting back to the surface every once in a while. And basically, a remote procedure call will make a call look local. You're calling over something, and that something looks to you as a developer as it's part of the monolith. Okay? So let's look at some code. We have this. You have an order, and you create an order for a specific request, and then you need to process the payment, and if the payment is successful, well, you will need to arrange the shipping for that specific order. If we were to look at this, everything seems to be part of the same application, or at least from the same abstraction of the application, right? But one thing that happens is whenever you call a specific method, there is a network call involved. And you might have the tendency to abuse. The code looks local, and you forget the network, and you tend to make additional calls. Okay, when you have, for example, HTTP clients that make calls to different services, those services are obviously different applications, and you make an HTTP call over the network, and you're more aware of that. So RPC, as a general concept, will make the code look local, and it's easier for a developer to get started with. It has a call a method approach. You do not need to instantiate a HTTP client, get and read the stream, and so on and so forth. And, well, it's kind of prone to errors if you're not careful enough. But the goal of an RPC is to make the network communication transparent, like make you forget that is there. So pretty much, it will make two applications that are distributed behave like a monolith. For you, the code will look like it's in the same solution, like it's in the same application. Okay? So enough with the history. Let's talk about gRPC. gRPC started in 2001 as being an internal project named Stubby at Google. In 2005, they open sourced it, and fast forwarding in 2019, well, we got it in .NET Core as being a first-class citizen. Okay, so what is gRPC? gRPC, it's a thing that is contract-based. You will need to create an interface definition. So you remember SOAP? Similar in this way with SOAP. But it will make you have no code references. So if you have a solution, you won't add reference, search for that project, and so on. So no reference to separate projects. And behind the scenes, it will use HTTP2. want it or not, HTTP2 will be used. And because of how HTTP2 is made, it's way faster. And it has an efficient protobuf serialization, which ends up with giving a smaller payload. And of course, it's available in many languages, including C++. What it does very well is code generation. It generates code for us, and it's very nice because with the click of a button, we get the code. Okay, so if we're to look at client-server architecture and requests from HTTP, now, if we introduce the proto file becomes the central point of truth. So the client will know the proto file, the server will know the proto file, and will expose methods. Okay, so now let's have a look at the proto file. Proto file, it's a file, simple, with the extension .proto that has a special syntax defined by Google, where you define the version of it, the namespace, the package that will be generated afterwards. And after that, you'll have the name of the service and the methods that are exposed. So in this case, I want to say, hey, I have a service that is called Fibo, and it has a method named compute Fibonacci that returns a Fibonacci result and gets an input named requested number. Well, in gRPC, you need also to define the representation of a request and of a response in the traditional way. So what we'll see here, it's two messages. This is the way that it's called in gRPC, messages. And these messages have properties. In C#, it will be translated as simple properties, named number, and named result for the Fibonacci result. What you see in there as an allocation equals 1, it's not an assignment. It's the order of the field because it has a binary representation. Okay? So what it does RPC very well is exposes 4 ways of working with data. And we're going to talk in depth about each one of them, and also we're going to look at some code. So first of all, we have unary representations. Unary means request response in a traditional way. You issue a request, kind of, and you get one response back. It's one-to-one representation. Another method of working with gRPC is server streaming. What happens in here is that the server will be able to send several chunks of data over the same connection. So it will have only one TCP connection, and over that, the server will stream several things. I have demos for this, so I'm going to also show you. Client streaming, well, the client sends several things to the server and gets one response back. And of course, bi-directional, which is a combination of the previous two. So let's have a look. gRPC, unary. If we were to map this in a similar and traditional way of request response in HTTP, it will look like this. So the client issues a request, the server receives the request and sends a response back. How it looks in terms of defining this in a service is I have an RPC method named compute Fibonacci, receives a requested number type, returns a Fibonacci return type. So this is how unary looks in the code. The second method, or server streaming, mapped on HTTP request the traditional way. We have, okay, the client issues a request, but gets back several chunks of responses. Okay, how it looks? Similar to the unary one, except the fact that it has the stream part as a keyword in the result, which means that basically it will send back, it will send back a stream of this type, so several of those. Client streaming, again, similar, a request with several chunks over one TCP connection, and one response back. So this is how it gets mapped over a traditional HTTP request. Okay, this scenario is super nice, for example, when you upload things. If you have scenarios like uploading large files, you can chunk them and send them over one TCP connection. Getting data from the sensors, maybe. Something that sends several data somewhere in the cloud, maybe. So to collect data. And bi-directional streaming, a combination of the two. So the client sends several chunks to the server and will get several chunks back from the server over one connection. How it looks? Well, by having stream keyword added at the input and stream keyword added at the result. Okay, so big picture, it's kind of that's it. But in .NET 6, there are a few other gRPC concepts that we kind of need to talk. gRPC internals, status codes. We all know status codes, right? I know there are kind of 63 of them. We use like maybe 10 in a good manner. But status codes represent the actual status code of that request, okay? Well, in gRPC, that status code that we all know, it's not the same. gRPC will have its own status codes that it's up to you to map to the response. For example, you might get 200 OK over the entire response, but for the specific gRPC request, you might get an exception. It's still a valid scenario. RPC exception is the thing that you need to catch every time you work with gRPC and you expect something bad to happen. And from that RPC exception, you need to filter out gRPC status codes that are different from the status codes you all know. Interceptors. Interceptors are a gRPC concept that will allow you to interact with that specific gRPC request in a manner that you can inject or, I don't know, hydrate the responses. It's like injecting yourself in the pipeline for that specific gRPC request. And you will have 4 types of interceptor specific to each of those methods. So unary, server streaming, client streaming, and bi-directional. So if you have scenarios where you need to add a header, maybe, you can add an interceptor, and that interceptor will be called whenever your gRPC call will be made. Request headers, well, the request headers are simply headers from the classical HTTP. Response headers, the same. You can add some extra bits in there as being key value pairs if you want to transport extra information. And something that is kind of new, it's these response trailers. So you have 2 kind of things that you can add on the response. A response trailer is something that is sent by the server at the end of the response. It's like an additional set of headers because the way of HTTP2 is made. Okay, so what we can tweak in gRPC service or in gRPC in general in .NET. When we create a project in services, the middleware has a lot of things that can be fine-tuned. One of these are enable detailed errors. If you want detailed errors regarding this gRPC, you can set that flag to true. Also, you can limit or increase the limit regarding the message size. So for each request, you might need scenarios where you say, hey, I don't need more than 1 megabyte for each request. And you will be able to modify and add it here. Maybe you need some compression. It's always a good scenario to have compression to the response. So you can add this here. You can have different compression levels. You can have optimal, or you can look into that error in there. You can specify what is the compression algorithm. You can have gzip or whatever it's suitable for your scenario. And also, if you want to create your own compression provider, you can go ahead and plug that in. You can create eye compression provider, you inherit that, you implement the interface, and you implement the logic yourself, or you use something that is existing. And also, you have a way of adding the interceptors in there. So create your interceptor, add it in there. Security related, I'm not going to talk too much. I'm just going to specify a few things. What is supported? So it's supported in two places, at the channel level and at the connection level, and everything that we know from APIs. You can add them on in here. So enough with the talk. Let's see some code. And first of all, I'm going to show you how a project looks. OK, so how do you create a new project? Go ahead. OK, so using the specific client, sorry, I need to repeat the question. So the question is, if you enable a specific compression level, how do you make a consumer basically understand that specific compression? You need to also add this to the client to be able to match those. And you're able to do that using gRPC net client. So first of all, if we're talking about gRPC, we're still talking about the kind of API, right? And that API still has something that we know. So I'm going to start by showing you a proto file. I hope the font is big enough to be seen from behind of the room. So what I have here is a service. It's interface definition language. It's similar to the WSDL, if you remember from the SOAP. You specify it in here. And then I have 4 methods specified. One is unary, server streaming, client streaming, and bi-directional. These are very similar in terms of the difference is this keyword stream. Okay, so this streams the response, and this streams the input, and this streams the input and the output. Cool. I created 2 messages named. I thought it would be easier to understand by mapping to what is the request and response in HTTP for a web API. So I named my message request, and it has a field name content value. And the response, I named it a response, and it has a message. Okay? So this is the proto file. The cool thing about the proto file is that it will stay on the server, and after you build this, it will generate a stub for you. So it will generate something that you will be able to override. So each of those 4 methods, you will need to specify an override and to give an actual implementation. Okay? So how it looks. The first method, the unary one. The unary one receives a request, that message that has only one field, and it has an additional parameter named server call context. This context is similar to HTTP context. It gives you access to the actual thing that is sent. So from here, you'll be able to do something like that and extract the actual HTTP context that we know from Web API. And also from there, you can extract information about the user if you have some authentication added in there, and get the claims, for example, if you have something implemented. Or maybe you want to have the client certificate that is also set in there. Or maybe you also need to get the request headers. And those request headers are the actual HTTP request headers. So not specific to the gRPC thing. So context, you get that, you access that, you have request headers, and you pass the key that you want to extract from there. Key value pair, nothing complicated. Also from here, you can do something else. You can add response trailers. Remember the thing that is specific to gRPC that is sent at the end of the body of the request, named trailer. So how you add those? those are added just by using the context, so the current call context, response trailers, and you add this thingy that is called metadata entry, which is nothing more than a key value pair. You add the key and you add the pair, and that's it. Okay? So from here, it's your job to implement what is actually needed in that method. Okay, so I'm gonna show you a demo. So in here, in this window, we will have a server that runs. So I'm gonna do .NET run, and this server will hook to a specific port and wait for requests. So you see it's in localhost 5000, and it waits for requests. And in this other side, I'm going to have pretty much the same thing, only that is a client that will call the specific method. So I will also show you the code for this. The code will be on GitHub, and you'll be able to look around it. So what I have here is a set of console apps. Is the easiest way of displaying things. So Unary console app is a program CS that uses nothing else, nothing more than a few packages. And those packages are gRPC and gRPC net client and ASP.NET Core, because I want to show you two types of using things. For example, when you're talking about gRPC, first you need to create a channel. So a channel is a thing that opens a TCP connection, and from that channel, several pieces of data can travel back and forth. So with a channel, you can talk with the server several times on the same TCP connection. So it's like, okay, open the communication way once, and then chat whenever you want. So this is the implementation by using gRPC net client. So this package is not done by Microsoft. You find it in NuGet Package Manager, and it has a sort of different syntax, but in the end it does the same. You specify, hey, I need a channel for this address, and this channel has a few options, and those options are regarding credential. The most common example you'll find is this insecure thing. You need to add it to be able to actually make the request, the gRPC request. Otherwise, you will need to add there whatever the solution is. JVT or any other kind of authentication, it's here where you add that. Okay, so from here, you need to, well, instantiate the client. I want to specify that here, I didn't implement the greeter client. It was generated for me. The only thing that I implemented was the actual greeter service that I override the methods. But here, the greeter and greeter's client, it's made for me. Okay, what you can have in here is just, okay, instantiate the request. You'll need to pass this request in your method call. Okay, so you have say async hello, pass the request message. You cannot have empty here, there, or null. You need to pass something with a specific field. And in here, you are able to have a few things. For example, you can specify a deadline. For example, if I'm not getting the response back in 5 seconds or milliseconds, just consider this as being, okay, expired. Don't do it anymore. Or maybe you need a cancellation token. After a while, if something happens, you will be able to cancel that request. Okay, so this is the complicated version, the complicated overload. But in here, I'm going to show you the easiest one. Okay, so I'm going to open the server. It's still listening. And in here, I'm going to do a .NET run to make the client make an actual request. Okay, so let's see what happened. After .NET run, I sent a message, hello world. That's the console, and I'm sending NDC. And what I'm getting back is hello back with NDC from localhost 5000. Okay, so let's see on the server side what happened. On the server side, you'll see that it's an HTTP2 request made, and it's a post request. In gRPC, you do not have verbs. You have post, and with post, it's what you get. So if you're talking about caching or anything like that, you can forget it. So everything is a post. Even if you get data, it's still a post. And if you were to look at the URI, you'll see that it's localhost port number, greeter, say hello. And that say hello is basically the method that was called on the server side. What you get is application gRPC, 200 is the status code, and the request took that amount of time. Okay? So if I were to run this again, you'll see another thing happening on the server and another response back. Okay? In the other side, let's see. I didn't show you, but if I look into the dependency part, I'm going to try to zoom in. I do not have a reference towards something, towards the service or towards anything. The only thing that we have here is a reference. By editing the project file, you need to add this, an item group, where you can specify, hey, include that proto file that you want to use, and gRPC services act like being a client. In here, you have two options, client or server. And based on that, he knows, okay, this is the client or this is the server, okay? So the path can be relative or it can be somewhere where every other project can have access. And in there, so this is the way of not having a project reference. So you treat this as being independent, but that independence is somehow apparent because you still have the proto file that you will need to take care of. What I did here is to navigate to the server protos, I mean, in the other project in here, but very well I could have had an upper level folder where I could have pointed every other project. Okay, so this is what you need to have a client. Okay, so, and the other part. Let's see the client streaming, how it looks. The client streaming, it's rather similar. I'm going to modify this because it's 5,000. It's still create a channel, have it as being insecure, create a client, and then call the method. I'm going to also modify this because it's too large. Call the method named client stream. That client stream, it has no apparent logic. It has a for loop that goes to this value and simply writes the value, makes the request with I. Okay, and what we're having to have here is the response. We need to sort of wait and see that the request is done. Okay, so what I'm going to do, it's still here, the server, waits for the request, and I'm going to have another console app in the right-hand side, .NET Run, that will issue requests. So because it's a client streaming, cool, failed to connect to all the addresses. Let's see, 5,000, it works. I didn't save. I'm going to show you also how you can specify a range of ports to connect. So clear screen, run. So you see, on the server, you get values, and several of them. So which means that the client sends things. It's one TCP connection in there, and it sends a lot of things. What you can see here is the method client stream that was called, 200 OK as a HTTP status code, and application gRPC. Okay, and in here, the response to the client was the last I that was sent to the server. Okay, so this is what received as next value. Cool. The next part, server streaming. I'm going to use the same approach and then dig deeper. But first, I'm going to show you something regarding the RPC exception that I talked about. So in case something happens, you have the RPC exception that you can catch. And you can treat it differently by filtering the status code. And remember that status code, it's not HTTP status code. It's related to gRPC. And if we were to look at here, we have aborted, already exists, canceled, data loss, deadline exceeded, invalid argument, out of range, permission denied, unauthenticated, unavailable, and unimplemented. These are not status codes, but they're specific to gRPC. Okay, so based on that, you can also throw RPC exception with the specific gRPC status code to be able to tell which is which. Okay, back to the server streaming. The approach is the same, but this way, 5,000, to make sure it works, you send basically several responses to the client, but the client is still the one that needs to instantiate the request. And here I'm going to show you the trailer values. Okay, same when something happens, you can write something in the console or log or whatever is the case, and it's still the same. Server is listening, and I'm going to run the client, .NET run. And you see the client streaming, send stuff to the server. You see server streams. And also the client found some trailer values, key value pairs sent at the end of the response. Okay, bi-directional, it's similar. Okay, we're sending, but at the same time, we'll also writing things. The same approach, server is listening, and bi-directional with .NET run. Let me make sure I have the right port in there. Yep. And this and this. The order is not guaranteed. Okay, so I'm sending the same I until 10 in the for loop, and I receive the messages with I back. Okay, so this is how it works. If you have a specific scenario for this, go ahead and use it. It's very performant. And we're going to talk a bit about what else we have in gRPC in .NET 6, because we have a lot of things that are pretty awesome out of the box. So why use gRPC? I also have another demo for that. Benefits. Well, performance insights. If you have scenarios where you have an HTTP client or REST API that talks with another server, point-to-point communication, then, well, why not use something that is way performant? Okay? Allows you to have polyglot environments. If you have Go or any other language, you can also use gRPC to have a binary communication between them. It has low network usage because the response is way smaller. Useful to point-to-point communication, and it has multiple calls over a single TCP connection, which is, I think, one big benefit. So it's contract-based, smaller payloads, it's way faster, and it's out of the box, and if the browser supports it, and we have scenarios server to server, why not use it? Streaming types, .NET 6, and also it can be configured to run with HTTP 3. I don't know about you, but I'm just getting starting with HTTP 2, and they're talking about HTTP 3. And I feel like it's kind of getting ahead of me. So what does gRPC does awesome in .NET 6? Well, how about this out of the box without installing additional things? It does transient fault handling. You can configure some things like how to behave in case of network failures. For example, you can have something like this. You can't name your default policy or use a default name. You can configure the maximum attempts. You can say, hey, when do you back off on retrying? Maximum back off on how many seconds, multipliers, and status codes. So basically, you tell this, hey, when you try to apply a retry policy, when you encounter this status code. And this status code is the one from gRPC. Also, you have another option of having hedging policy. You can define that, advanced things from transient fault handling. And also, you can work this out. Also, what you can do is define this. And from this, you can also load balance, which is a thing that I really tried, and it's very nice. Client-side load balancing out of the box. I mean, you'll specify a range of addresses or a DNS, and it will try to connect based on the policy you specify on a server or another server. For example, you can have a DNS resolver factory or a static one if you know the ports. And you have two kind of policies like pick first or round robin, or why not, you can implement your own. It's very, very easy to do that. So I'm going to show you this. So I have the server running. I'm going to have another server running. Okay, just a second. I'm going to copy because I didn't want to lose this. So what will happen is I will have two instances to simulate, like, I don't know, a Kubernetes environment. One is on port 5000 and one it runs on 5002. Okay, so two server. I'm going to leave this here. And in here, I have a unary call, so a simple request. .NET run. And I'm going to run this several times to show you that once it gets it from one port and once it gets it from the second one, without me doing anything special. So still 5000. See? So 5000 and the last one. So how I did this is to simply create a static resolver factory by adding an array of balancer addresses. I have localhost 5000 and localhost 5002. So this, I know the ports, and this is how I'm specifying it. And then I'm going to register in the dependency injection the factory. And then I'm going to create, okay, for the address, I have a static policy, namely my example host. It's insecure because I'm not adding anything related to the security. And as a policy, use round robin. And of course, set that on the service providers. But the important bit is over here. You can specify which are the ports if you know the ports. Or if you have DNS, you can have something like this. You can add the DNS resolver factory. And you can leave that to be refreshed every other time. I don't know. So if you have Kubernetes, for example, and you have other pods spinning up, you can connect to those automatically without you, I don't know, tweaking things. So instead of static, here will be added DNS, and it will know how to connect to that. So this is what out of the box .NET 6 gRPC does. This thing is pretty new, and I thought it's awesome that they implement that. I'm thinking about Blazor scenarios, for example. How cool it is to have, you know, Blazor instances running in Kubernetes or whatever, and just spin new instances and let the service connect to those. Okay, so policies that you can configure. Pick first, round robin, implement your own if that's the case. So pretty cool so far, gRPC. Because, for example, when someone starts with microservices, they first start on doing HTTP client calls to get data from one side to another. We're talking about microservice architecture as being the silver bullet. Everyone wants to work with microservices. But sometimes those microservices add overhead, and we need to manage that overhead. So while you're young with microservices architecture, you do HTTP client calls. I did that until I moved to service buses or any other tools like that, RabbitMQ, ActiveMQ, or whatever. But HTTP clients is the easiest way of getting data over the network from one side to another, right? But if you have that, why not use a technology that is actually faster? So what are the downsides? Well, the downsides is that you won't have the same benefit of using a queue, for example. You need both systems to be up in order to make them communicate. So another thing is that as a developer, you might forget that this network. You call the method, it's very familiar. And it's not human readable until now, because Postman did a very awesome thing. I'm gonna, just a second, I'm gonna stop this. Postman. You all know Postman, right? Postman has a thing that is in beta now. You can add new, you have gRPC request. And from that gRPC request, you need to specify what's the port of the server. And you have a way of discovering the protobuf file. You can use server reflection, or you just can import from local file, which is I'm going to do. I'm going to hit next. Here you can add API definitions, added versions, and so on, but I'm going to use it without importing. And what it does is to discover the methods you're having in that specific proto file. Okay, so say hello, client streaming, and so on. So if I were to select one of these, I can generate an example response. They can look here, and it will generate message request for us. And also, you can invoke the method. You see, invoke is very soapish, invoke. But either way, it works, and it has a visual representation. One major drawback of gRPC until now was that you had binary, and that binary file was not human readable. Okay, so here it is. Message hello back with whatever I sent from the specific port in there. And it's pretty awesome. It's still in development, so don't expect it to work at its full potential. But it's here for us to use. Another tool is Bloom RPC. Maybe if you worked with gRPC before, it's familiar. You can find it on GitHub. If you Google it, Bloom gRPC, it has the same approach. You specify a port, you import a proto file, and it will discover the methods that are available. And from there, you'll be able to hit play and execute the requests, which is pretty awesome nowadays. OK, so getting back to the downsides, you need better testing with gRPC because you have a single point of truth and a single point of failure. If that proto file is changed and, well, you're not taking care of the other consuming services, things are happening. You need to focus on CI/CD. There is also a talk on YouTube from a guy from Spotify. Spotify uses gRPC, and they talk about how they migrated to gRPC and how they have a single repository with gRPC files, and they take everything from there. Drawback is that you have HTTP post. Even if you're sending, if you're getting data, HTTP post is what you use, and there is no way of changing that. So there is no HTTP caching or caching at the transport level. Single point of truth, and the biggest one, that is not supported in Azure yet. It's still work in progress for about 2 years. I don't know what's happening, but it's still work in progress. To overcome that, if you use Kubernetes or Docker or anything like that, it works. If you also use servers, like you manually installed servers, you can have gRPC services running in there, but not Azure as services. Okay, to overcome that, they have an implementation called gRPC Web, but in that you cannot have server streaming and client streaming. So, well, okay, so gRPC versus REST. It's not really about versus, but we need to have a familiar comparison. So REST or HTTP APIs are very resource focused. You're working with resources, you expose things over the wire. Well, RPC embraces developer semantics and is action-based. Do that, call that, act on that. You have loose coupling in HTTP, or you should have. If you have an HTTP client that is strongly typed, you do not have loose coupling anymore. Because this is a scenario where we're talking about server-to-server communication, not browser to API. Okay, browser to API, it's a different other story called gRPC Web that it's still in development, and it deserves a different talk on its own. RPC has a tire coupling. You have that proto file that you move around and you act on that. The first one is text-based, and the second one is binary-based. But that binary-based used to be a drawback until now. But thanks God, the guys from Postman actually made a thing that is visually and clickable and usable. Until now, you could have used gRPC curl. There is a version, C URL for that. But either way, when and why gRPC overall? So gRPC, I think, in my opinion, it's it worth your time if you have server to server, get data from one side to another. It has a lot of performance benefits. It's way faster. The payload is smaller. And it has client-side load balancing. It's worth mentioning. And retry policies out of the box. If you need something advanced, you can go ahead and tweak that and read more about it. Great choice for microservices. Point-to-point, replaces HTTP clients gracefully. And those 4 modes, if you have scenarios like that, with moving data from one side to another in big chunks, I think it's notable. And it decouples code. You won't have references that references something else and ends up being a spaghetti references and so on. In my opinion, an alternative future of web APIs would be around no more hunting for documentation, like no more, I don't know, a Swagger file looking what do I have to create, what do I have to add in there, and no more misinterpretation of status code. I remember the talks about, what do you send here? Is it bad request or is it 422? I mean, regarding the error processing. And also, no more data parse errors. No more forgotten fields. No more, I don't know, fields that should have been named with underscore and so on. So, about distributed systems, these are about trade-offs. And because these are about trade-offs, we cannot have a technology or a tool that will solve all problems. We just need to pick the right technology for us, the right scenario. So that's why we should need to know about the tools. I also added in here some next steps to look into if you're really interested. gRPC Web, James Newton King has a few talks about it on .NET channel. HTTP 2, and of course HTTP 3 now, of course. And of course, proto syntax, because if you have complicated scenarios, you might need to have a look on those. Okay, Postman, it's in beta. gRPC curl, if you are in need of a tool that makes requests, gRPC requests, and Bloom RPC. Another thing that I want to mention is these 2 books. If you've been to Mark Randall's workshop, you might know about that book. It's free. And this one is Antonis Giretti, Beginning RPC with ASP.NET Core 6. He has a lot of examples in there that might help you. And of course, if you need, you can DM me. Thanks for listening. You have the slides there, Embracing gRPC, a bit.ly. The slides and the source code and everything, you have those uploaded in there. And also feel free to reach out to me. I'm here. And thank you for listening.